सॉरी लास्ट बार डिस्टर्ब कर रहा था। कौन सा पेज पे है?
What beta?
कौन से पेज नंबर पे है सर?
13. Page number 13. Yeah. If you could scribble or write, it would be better. Those who are those who or don't have or those who don't have hard copy or iPad or anything, just make sure you write it on your books. Okay. Because this part you need to learn deriving it as well. Generally, when it comes to metallic conductors as in any metal rods or many metal wires also have resistance. This we have learned in 9th, 10th standard. And the resistance of that metal wires will be proportional to the length, how much length it has, and inversely proportional to uniform cross-sectional area. Reason being is, see, when it comes to flow of electrons, right? Electrons are flowing through the small wire, so their intensity is very high. That is, number of electrons flowing per unit area per unit time. Okay. So because wires are very wire comparative to the volume of electrons which are coming inside, correct? So they are at a much higher volume. So density is very high there. So passing through that wire becomes a challenge. Clear? So if you have a bigger, which you have a broader wire, okay, or the diameter of the wire is more, so more amount of electrons can be passed with ease. And that's why if you have more area, cross-sectional area, you will have less resistance. If you have less cross-sectional area, you will have more resistance, correct? So R is directly proportional to L and R is inversely proportional to L. So resistance, we will see, resistance R would be directly proportional to L by A. Okay. If I remove the proportionality, I'll get one proportionality constant as rho, and this rho is called as specific resistance or resistivity. The term that as resistivity. Now students, usually when we use the term specific resistance or resistivity, these terms, how do we define them? See, how will we define here? So rho will be equal to R into A by L, correct? So we define this the way that for a unit cross-sectional area of a wire of a unit length, the amount of resistance that wire can exhibit is what we call it as specific resistance. ऐसे ही पढ़ते ना? So specific term is being learned when you have it for a unit unit dimensions, correct? So that is how we need to build up all the definitions in this particular segment. Okay. Second, so L by A is a very specific term which we'll be using. This is known as cell constant, and cell constant depends on dimensions of the conducting units or material. Conducting units or material. All right, this is called cell constant. Cell constants is not very familiar when it comes to wires because it is much easier to calculate length and area there. But cell constant becomes very important when you have conducting cells where we have some electrolytic solution, and there we are trying to measure resistance. In those cases, cell constant becomes very important. Now, if you write this resistance as 1 by R and this as 1 by rho into A by L, correct? So I can write the same equation in this format. This 1 by R is now defined as conductance. This is defined as conductance. Conductance in NCERT is both taken as C or G. So you can take both. All right. So C or G is equal to 1 by rho into A by L. And 1 by rho is defined as kappa. This is defined as kappa, known as conductivity or specific conductance. So kappa here we define as specific conductance or conductivity. Clear? So here G or C is defined as kappa into A by L. Kappa into A by L. Okay. Now, cell constant L by A is represented normally as G star or G hash. Okay, G star or G hash. You can take any of that. From here, you can see we can define this kappa, define this kappa as C into L by A, which is equal to C or G into G star. Correct? C can be interchanged as G, and G can be also interchanged as 1 by R. So G star by R. This would be using a lot in this particular topic, that what is the cell constant and how it is related with specific conductance. Okay, formula wise itna hi hai. Okay, formula wise if you look at it, this is the one. Now let us come on the basis of units. What are the units we will observe when it comes to cell constant? Units of G star would be L by A, which means if you take centimeters, you'll have centimeter inverse or meter inverse. Correct? If it is SI units, that will be meter inverse. Next, if you see it for resistance usually we use this as ohm units. And when it comes to G or C, that is conductance, we use it as ohm inverse. We'll use it as ohm inverse, also known as mho, MHO, mho. All right. Right. So ohm inverse or mho. Now, once you get this, here we can replace as G or C can be replaced here. Got it? And what will be the units of kappa then? Kappa would be equal to G into G star. G is ohm inverse and G star is meter inverse. So therefore we'll have ohm inverse and meter inverse. And ohm inverse is normally used as Siemens, Siemens, correct? So Simon, which is S, correct? And here ohm inverse and Simon are same. So I can write kappa as Simon meter inverse or Simon centimeter inverse. Okay. So this data is useful for us because this chapter mostly deals with conductivity rather than resistance. Clear, students? Units wise, सबको clear है ना? Any doubt there? Now, have you all made a note?
नो सर, वो नोट करने के लिए टाइम दे सकते हो 2 मिनट मिनिमाइज करके?
Sir, what is that written? G or
G or C. G or C. Conductance can be written as G or C. I would suggest all of you to frame your own definition for kappa, that is conductivity, molar specific conductance or conductivity. You can see for unit dimensions of the cell, which includes unit length and unit cross-sectional area, the amount of conductance which is seen in that unit, in that material, is what we call it as conductivity. Done, everybody?
सर मुझे 2 मिनट और लगेंगे, आई एम सो सॉरी।
क्या बेटा, कोई बात नहीं, आप करो।
सर आप एक बार मिनिमाइज कर सकते हैं क्या?
या
थोड़ा सा ऊपर लेके जा सकते हैं
या
पूरे? यस सर, हो गया।
now
सर
look at this.
इलेक्ट्रो कंडक्टर से भी लिखना है क्या?
क्या बेटा, ना ना, जो इंफॉर्मेशन मैंने वहां पे नहीं दिया, जो आपको प्रैक्टिस करना है वही लिखा रहा हूँ आपसे। सिर्फ ये प्रैक्टिस करना है आपको, ये सारे डेरिवेशंस। ओके, कहाँ से स्टार्ट हो गए, किसको क्या रिलेट कर रहे हैं, वो प्रैक्टिस होना चाहिए। ये सब थ्योरी है, इसका जरूरत नहीं है, ये हमने ऑलरेडी दिया है आपको। देखो, नाउ सी इन दिस इलेक्ट्रोलिटिक कंडक्टर और इलेक्ट्रोलिटिक कंडक्शन cells, here what we are doing, we are trying to make electricity pass between two uh, right, between two electrodes. Suppose if I have an electrode here and here, one is positive and negative electrode, then between these two the circuit is getting completed only by the movement of ions. There is no wire in between them, which means exactly in this much amount of volume, if you see, this is the volume, correct, which is present here, this much volume, it is a volume of that box, right, in which the ions are moving, correct, in which the ions are moving. And we need to precisely understand how much is the resistance which is occurred in that volume, or how much is the conductance which is happening by the ions in that volume. Got it? So now the cell constant in conducting cells where electrolytic solution is present will be between these two electrodes in that particular volume. And how do we define cell constant in that case, students? It will be length which is separating these two electrodes, and the area is the area of this cross section for anode and cathode. For most of our cases, we will be taking anode and cathode as the equal area. Got it? So that we will have a simpler volume defined. Clear? So the area of this and this would be same, and the distance between them, the distance separated between the electrodes is, we call it as L. So cell constant in conducting cells will be L by A. Okay. Rest all definitions are still valid, whatever we have derived above. Okay. Now, what is the main difference between a metallic conductor and an conducting and a electrolytic conductor? Metallic conductor and an electrolytic cell conductor. In metallic conductor, conductivity of a metal depends upon first nature and structure of the material, and nature in a sense how many valence electrons it has. Got it? For example, if you take uh, metals like cesium or lithium, they are very brittle, although they might have very ease of giving electrons, but they are very brittle, they break down very easily. But if you compare to the compare to iron, copper, correct, aluminum, okay, so they are malleable, they are ductile, and they have sufficient number of unpaired electrons as well. Got it? Now, if you see zinc, zinc is not very well conducting as that of copper or iron. Okay, so reason being is number of electrons which are transferring, correct. So unpaired electrons are more when it comes to iron or copper, correct. Zinc has mostly paired electrons. It does not mean it won't participate, which means the conductivity as compared to that of iron and copper will not be same for zinc, and that can be pursued based upon the electrode potential, reduction potential. The one which has more reduction potential, which means the ion has more tendency to attract towards electrons. Clear? So therefore, In metallic conductor, when you're only talking about metals, not in electrolytic cells, in that case, we will only discuss about the nature and the structure of material. That is how many valence electrons it has, how much participation of electrons will be seen, and what is its crystalline structure, whether it is BCC, FCC, HCP, what type of a structural identity it has. Copper, for example, always have FCC nature. Zinc will have HCP nature. Iron, FCC. Correct? So based on that, the material strength will also depend. Okay. Second, on increasing temperature, resistance of metallic conductor will increase due to increase in the hindrance of the movement of electrons. Because when you increase the temperature, all the atoms will start vibrating on their main position, because of which the flow of electrons will start getting restricted. Okay, because as the electrons comes over, right, so there is not an easy transfer of momentum to the next electron, because they have to keep moving on the mean position as well. Okay, so because of which energy gets more distributed in all directions, so it does not become easy for movement of electrons from one end to the other end of the electrodes. Clear? So increasing temperature decreases conductivity. Clear? Or increases resistance because it has more hindrance for the movement of electrons. Correct? Coming to the electrolytic conductor now. These are the two main pointers, which you have to focus on. First, electrolytic conductor depends on the nature of electrolyte added. That is it a strong electrolyte? Is it a weak electrolyte? For example, I took NaCl and added to the water, and that will become ions. That will give ions. But is it going to get 100% dissociated or not? That makes a lot of difference for number of ions. For example, if I take calcium carbonate, it won't give many number of ions there. So therefore, it will not show much of conductivity. Now, from here onwards, we'll start sticking to our mind the conductivity, irrespective of whatever type of conductivity, whether it is specific conductivity, whether it is molar conductivity, equivalent conductivity. There are many types of conductivities. All conductivities, irrespective of whatever the dimensions and quality, they depend on number of ions. More the ions, more is the conductance. Yes, students? It's pretty simple. Relate that to same as electrons. More electrons, more is the potential difference, more is the flow of electrons. In a similar lines, if you're taking an electrolyte, the primary thing you need to see that how many electrolytes, how many ions it can generate. Okay. So if it is a stronger if it's a stronger electrolyte, strong electrolyte means which can dissociate 100%. Weaker electrolyte like acetic acid, for instance. Acetic acid does not give 100% ions. So it is a weak electrolyte in water. NaCl is a strong electrolyte. HCl is a strong electrolyte. Okay. So first factor depends upon is the nature of electrolyte. Second factor, the size of the ion produced and their solvation. Now, typically this we will be learning a lot in inorganic. First, I'll give you one example. Rest of them will be anyway discussing inorganic. When it comes to S block elements, on adding it to water, they always get easily hydrated. The reason is they have high reactivity in water. All S block elements starting from lithium, sodium, potassium, rubidium, cesium, all of them, when you add it to water, they will lose electrons and they become ions. Lithium plus is a very small ion, and we have learned this in chemical bonding. The smaller ion, more is the hydration around it. More amount of water molecules will accumulate around it. Now, when the lithium has to move, along with that, there is a lot of water molecules which will also move, which means the hydrated lithium ion is very bigger in size, right, students? While when it comes to cesium plus is bigger, but the hydration around it is less. At least compared to that of lithium plus, it will get less hydrated. Now, if you compare cesium plus with all the water molecules around, lithium plus with all the water molecules around, then lithium plus will be bigger compared to cesium plus. Okay, students. So I'll just write down that here for example sake. Lithium plus aqueous ion will be bigger in size. This is radius R plus as compared to that of Na plus aqueous, as compared to that of K plus aqueous, compared to that of Rb plus aqueous compared to that of Cs plus aqueous. So smaller the size, more is the hydration, more is the solvation. In case if it is in some other solution, it will be have more solvation. So more the solvation, more solvent molecules will accumulate, and more solvent molecule accumulates, it becomes difficult for the movement of ions. Correct? Now, when you think about resistance and conductance in conducting cells where liquid ions are involved, what should come to your mind? First thing, students, if they are ions, you think how easily they can move from one electrode to the other electrode. How easily means there should not be any restrictions. There should not be any other ions which are trying to come in between their path. Okay. So first thing, you will see how easily they are moving and how fast they are moving. Clear? How easily means there is no crowding for them. How fast means how much is the ionic mobility. So these two factors influence a lot in conductometric cells. Clear? So first thing, if the ion is bigger in size, it becomes difficult for it to have high speed. So ionic mobility is less. Okay. Second thing, if the concentration is very high, ions बहुत ज़्यादा डाल दिए आपने, like water में 1 molar NaCl, 2 molar NaCl, which is more conducting? 1 molar NaCl and 2 molar NaCl.
1 molar.
1 molar is better conducting. Now don't think sir उसमें तो number of ions ज़्यादा है ना. See, आपको 1 molar और 2 molar रख रहे हो same volume में ना. As long as the volume is same, so number of ions of a similar kind, if you put and if you keep on stocking them more and more, then उसका molar conductivity कम हो जाएगा. The number of molar conductivity means per mole, right? So per mole conductance would be easy when it comes to 1 molar, and per mole conductivity will be difficult if it is 2 molar. Clear, students? So these two factors. हाँ बेटा बोलो.
सर मतलब जो ओवरऑल कंडक्टिविटी है, मोलर नहीं बात कर रहा सर.
देखो अनलाइक मेटल इलेक्ट्रोड्स या मेटल वायर्स, वहां पे एक ही टाइप का कंडक्टिविटी डिफाइन, बट लिक्विड सॉल्यूशंस में आपको 3 टाइप ऑफ कंडक्टिविटीज डिफाइन करनी पड़ेंगे. हर एक का कंडक्टिविटी अलग से पढ़ना पड़ेगा. फर्स्ट है सिंपल कंडक्टेंस, जो कि डायमेंशंस पे डिपेंड करता है, जो कि आयंस पे डिपेंड नहीं कर रहा है, सिर्फ डायमेंशंस पे डिपेंड कर रहा है. सेकेंड है मोलर कंडक्टेंस, जो कि नंबर ऑफ मोल्स ऑफ आयंस पे डिपेंड कर रहा है. थर्ड है इक्विवेलेंट कंडक्टेंस, जो कि नंबर ऑफ इक्विवेलेंट्स ऑफ आयंस पे डिपेंड कर रहा है. ठीक है.
ओके.
तो उनकी डिपेंडेंसी अलग अलग.
सर अगर सिर्फ सर मतलब तीनों में से कोई भी दो एक साथ नहीं हो सकते, तीनों अलग अलग होते हैं.
एक को मोलर कंडक्टिविटी और इक्विवेलेंट कंडक्टिविटी दे गो हैंड इन हैंड. ठीक है. कॉन्सेंट्रेशन बढ़ेगा तो मोलर कंडक्टिविटी कम होगा, इक्विवेलेंट कंडक्टिविटी भी कम होगा. बट हो सकता है कि आपका सिंपल कंडक्टिविटी, जो कि सेल के यूनिट्स पे डिपेंड, वो बढ़ जाए, बिकॉज वो डिपेंड करता है सेल के यूनिट्स और नंबर ऑफ आयंस पे. तो इसी के लिए हम लोग उसको डिफाइन करेंगे एक एक टर्म को. ठीक है. सो पहले सिंपल कंडक्टिविटी क्या होता है, मोलर कंडक्टिविटी क्या होता है, और इक्विवेलेंट कंडक्टिविटी क्या. ठीक है. राइट. नाउ इन जनरल बात करो, मैं ये जो बात कर रहा हूं ये इन जनरल है. इन जनरल क्या है, चाहे आप किसी भी टाइप ऑफ कंडक्टिविटी को बताने की कोशिश करो, एक बिगर साइज आयन हमेशा लेस कंडक्टिविटी रखता है, चाहे वो मोलर कंडक्टेंस हो, इक्विवेलेंट कंडक्टेंस हो, या वो सिंपल स्पेसिफिक कंडक्टेंस हो. ठीक है बेटा. नेक्स्ट
सर इधर जब आप आयन बोल रहे हो, मतलब हाइड्रेशन के साथ बोल रहे हो कि सिर्फ आयन बोल रहे हो?
हाइड्रेशन के साथ बेटा. ओके. ओनली आयन मतलब सिर्फ मोल्टेन फॉर्म में होता है. मोल्टेन फॉर्म में इतना सोचने की जरूरत ही नहीं ना. मोल्टेन फॉर्म में ना कि इक्विवेलेंट डिफाइंड है, ना कि मोलर डिफाइंड है ना. इक्विवेलेंट तो प्योर फॉर्म हो गया. प्योर फॉर्म में सिर्फ स्पेसिफिक कंडक्टेंसी होगा. राइट.
यस.
नेक्स्ट, नेचर ऑफ सॉल्वेंट एंड इट्स विस्कोसिटी. ठीक है. सो ऑब्वियसली वेदर द सॉल्वेंट इज मोर पोलर, लेस पोलर. करेक्ट. Whether it is more viscous or less viscous. If it is more viscous, it is difficult for ions to move. If it is less viscous, it is easy to move. Correct. Next, concentration of electrolyte. Like I said, concentration which has more, preferably will have lesser molar conductance, correct? And lastly, resistance will decrease with increase in temperature, unlike metallic conductance. In metallic conductance, what happened? Resistance increased on increasing temperature, while here resistance will decrease in increasing temperature. Two reasons. First, electrolytes will have more dissociation. Most of the time when you add salt to water, correct, then if energy, if it is getting hydrated, clear, more amount of ions are released into it. So usually कोई भी salt को पहले ions में convert करने के लिए आपको energy लगेगा, which is endothermic in nature. So it will help in electrolyzing the ions. First. Second thing, if you keep ions at higher temperature, the mobility of ions is higher, because ions will move at a faster rate when they are at higher temperature. Clear? And there is no problem in terms of any agitation of molecules, because they are already anyway moving randomly all the time. Okay? So unlike solids, liquid में टेम्परेचर बढ़ाने से कोई वाइब्रेशनल मोशन नहीं जनरेट होता है. इट विल ऑलवेज बी ए रैंडम ब्राउनियन मोशन. क्लियर? So in fact, that Brownian motion will only keep increasing on increasing temperature. I think is this point making sense, everyone? So
Yes,
resistance will decrease on increasing temperature when it comes to electrolytic conductors. Clear? Now let us see what is this molar conductance, because there is always a slight difference when it comes to specific conductance and molar conductance. Okay. I've written it as a definition first. We'll try to understand definition and then we'll go to the derivation. See, it is equal to the conductivity of solution. Okay, conductivity of solution containing 1 mole of an dissolved electrolyte, such that entire solution is placed between two electrolytes which are 1 centimeter apart. What does this mean? Okay. Which means, suppose if you have electrolytes this way and there is one more electrolyte here. Sorry, these are electrodes. So there are 2 electrodes here, and the distance between them, if you see that, like this is the some kind of a cuboid which is forming, right? Now here, if you see that this entire volume which is covered in this entire volume which is covered in this is where we are expecting the ions should be. And how many moles? 1 mole. If I take 1 mole of an electrolyte and keep in that between this particular dimensions, which are separated by one unit distance, 1 unit, that could be 1 centimeter or 1 meter, depending upon whatever we describe. Okay, so usually 1 unit distance if you maintain, and if you take it that in CGS unit, you will say 1 centimeter. If it is in SI units, we'll say it is between 1 meter distance. Then how much amount of conductivity is observed is defined as molar conductivity. Any doubt here? बस definition based. अभी हम लोग देखेंगे इसको formula based कैसे define होता है. Okay. Lambda m is defined. Lambda means molar conductance, and molar conductance, and this m represents molarity, correct? And lambda represents conductance. Yes, that is defined as kappa by C, where C is concentration in molarity. Concentration in molarity. फॉर्मूला को समझना थोड़ा डिफिकल्ट लगेगा इनिशियली, बट डोंट वरी, जैसे जैसे प्रॉब्लम सॉल्व करते जाएंगे एक आइडिया जनरेट हो जाता है कि मोलार कंडक्टेंस क्या है. अभी फॉर्मूला बेस समझते हैं पहले. फॉर्मूला बेस व्हाट इट इज, दैट व्हाट इज kappa first. Kappa is specific conductance. We have learned this before. specific conductance, and units for specific conductance were Simon centimeter inverse. I'm taking everything in centimeters for our understanding. And what is concentration in molarity? Concentration in molarity is mole per liter. Okay. Acha, mole per liter can also be written as mole into 1000, right? Sorry, divided by mole divided by 1000 per centimeter. I can write that in centimeter cube per centimeter cube. I can write this, everybody. Got it?
Yes, sir.
So if at all I substitute that back here and I'll try to get that in units, what do I get? This will be kappa divided by, right, concentration now in mole per centimeter cube, means I have to
Centimeter
divide this
cube.
by 1000. So 1000 will come up. So kappa into 1000 divided by concentration in mole per centimeter cube. Got it? So here concentration, which is in moles per units, now will be in mole per centimeter cube. So now if you see the units here, so what are the units, beta? This is Simon centimeter inverse divided by per mole centimeter cube. So which will be equal to,
Sir, mole per centimeter cube.
क्या बेटा? हाँ, per centimeter cube. So which will be equal to Simon centimeter square per mole inverse. ये होता है molar conductance का units. So this is now molar conductance. Molar conductance is kappa by C. मैं आपको एक केस स्टडी जैसे बताऊंगा तो आपको थोड़ा मोलर कंडक्टेंस के बारे में आइडिया लग जाएगा. ठीक है, एक केस स्टडी जैसा समझते हैं. देखो, सुनो सब लोग. सपोज यार ये सिचुएशन में हम लोग ने क्या किया, ये पहले सेल यूनिट्स थे. सेल यूनिट 1 सेंटीमीटर डिस्टेंस है और 1 सेंटीमीटर डिस्टेंस सेपरेशन है. ये दोनों के बीच में 1 सेंटीमीटर डिफरेंस सेपरेशन है और ये भी 1 सेंटीमीटर है. सो 1 सेंटीमीटर होगा तो ये ओवरऑल एक वॉल्यूम जनरेट हो जाएगा क्यूब का, 1 सेंटीमीटर क्यूब का. राइट एवरीबॉडी? आई थिंक ऑल ऑफ यू आर एबल टू पिक्चर दैट.
यस सर.
ठीक है, तो इसमें हम लोग अज्यूम करते हैं कि पहले कुछ आयंस थे बेटा. इसमें कुछ नंबर ऑफ आयंस थे. ये टोटल मिला के 1 मोल बन रहा है. 1 मोल आयंस ईच, मतलब पॉजिटिव आयंस 1 मोल, नेगेटिव आयंस 1 मोल. ठीक है, हाफ ऑफ मत सोचो. 1 मोल ऑफ इलेक्ट्रोलाइट होता है लाइक 1 मोल ऑफ NaCl. 1 मोल ऑफ NaCl मतलब 1 मोल ऑफ Na प्लस एंड 1 मोल ऑफ Cl माइनस. ठीक, अब ये सोचो अगर मैंने इसको डाइल्यूट किया. ठीक है, डाइल्यूट करने पर मेरे पास दो तरीके. अभी डाइल्यूट करेंगे तो क्या करेंगे? डाइल्यूट करेंगे तो जो इतना अमाउंट ऑफ वॉल्यूम था वो वॉल्यूम को बढ़ाना पड़ेगा. यही एक ऑप्शन है अपने पास, है ना. सो वॉल्यूम को बढ़ाएंगे तो क्या होगा? देखो, अभी जो प्लेट्स है, प्लेट्स की एरिया को बढ़ाना पड़ेगा मुझे थोड़ा सा.
यस सर.
इस तरह से. सो मैं डिस्टेंस यूजुअली चेंज नहीं कर रहा हूं, मैं सिर्फ एरिया को बढ़ा रहा हूं. ठीक है, तो ये यहां से यहां तक हो गया, ऐसे ऐसे, ये. ठीक है, अब क्या हो गया डाइल्यूट करने पर? सो हियर वी विल हैव ऑल द सॉल्यूशन इन दिस, सॉरी, नंबर ऑफ आयंस इन इट. अब ये जो आयंस है, दे आर नाउ ऑक्यूपाइंग मोर अमाउंट ऑफ वॉल्यूम. ऑलमोस्ट डबल हो गया वॉल्यूम, और जितना भी आपने इंक्रीज किया वॉल्यूम को. दिस इज व्हाट हैज हैपेंड. ओके, नाउ टेल मी what happens to conductivity, specific conductivity या specific conductance. specific conductance को क्या हो रहा है?
डिक्रीज होगा.
क्यों
सर? क्योंकि रेजिस्टेंस इंक्रीज. एक मिनट.
नहीं, मैं क्या बोला, ध्यान से सुनो.
Sorry,
मैं इसके लिए एकदम
इंक्रीज होगा.
अभी सब लोग बात करेंगे आपस में, बात करने से ये रिजॉल्व होगा, नहीं तो ये हमेशा समझना डिफिकल्ट होता है. सब लोग सुनो, मैं क्या पूछ रहा हूँ, स्पेसिफिक कंडक्टेंस कैपा के बारे में पूछ रहा हूँ. Tell me what happens to kappa in this case. Suppose initially kappa is kappa 1. Now it is kappa 2. Is it same? Is it different? Whether it is greater, less than, that's what you have to tell me. And justify it.
सर सेम होना चाहिए ना?
सेम होना
सेम
चाहिए,
होना
ओके।
चाहिए
एक
तो
है,
क्योंकि
एक
area
ऑप्शन
कट
है
जाएगा।
सेम होना चाहिए, ठीक है। और एनीबॉडी एल्स?
So can you once again repeat changes क्या किया है?
ओके बेटा सुनो, दिस वाज द इनिशियल सेल जिसमें ये 1 सेंटीमीटर डिस्टेंस है, मतलब 1 सेंटीमीटर इलेक्ट्रोड प्लेट्स है, 1 सेंटीमीटर डिस्टेंस सेपरेशन है, और उसमें 1 मोल ऑफ इलेक्ट्रोलाइट है। समर्थ क्लियर है यहाँ तक?
Yes,
उसको
sir.
मैंने डाइल्यूट कर दिया बाय एडिंग सम वाटर, ठीक है। अब डाइल्यूट करेंगे तो वाटर को अकोमोडेट कहां करोगे आप? वाटर को अकोमोडेट करने का एक ही तरीका है, इलेक्ट्रोड्स का प्लेट जो है, प्लेट्स का आप सरफेस एरिया बढ़ा दो, है ना।
हाँ, yes, sir.
ताकि अब ये पूरा प्लेट हो गया, ये पूरा एक प्लेट हो गया, अब ये प्लेट हो गया, अब ये प्लेट में ये डिस्टेंस चेंज हो गया, ये डिस्टेंस कुछ नया है। ऑब्वियसली दिस इज ग्रेटर देन 1 सेंटीमीटर नाउ बिकॉज़ यू हैव इंक्रीज्ड द डिस्टेंस नाउ, ठीक है। नाउ दैट इज वेयर माय क्वेश्चन इज, इन दैट केस फर्स्ट केस 1 और केस 2, मतलब ये दोनों केसेस में कैपा का वैल्यू कैसे रिलेटेड है दोनों से?
सर सेम रहेगा।
एक आंसर है सेम रहेगा, बाकी और जस्टिफाई करो बेटा उसको, क्यों से?
सर जो वो मतलब इलेक्ट्रोड का प्लेट का ही साइज बढ़ा के ना, दोनों के बीच का डिस्टेंस चेंज नहीं किया ना?
नहीं, डिस्टेंस चेंज नहीं किया। डिस्टेंस
सर
चेंज
रीजन ये है कि k is equal to c upon a, तो c is equal to k upon a, तो a कट रहा है, तो c is not dependent on area, sorry k is not dependent on area.
k is equal to
Oh,
c।
sorry.
सर
हाँ तनिष,
सर मुझे वहां पे समझा, जहाँ पे सॉलिड मेटल था वहां पे मुझे कंडक्टिविटी समझा सर, के वाला कैपा वाला, पर
परफेक्ट।
यहाँ पे कैपा क्या है सर वो नहीं समझ रहा सर।
सर
पहले
क्योंकि
तो वो
वहां
समझ,
पे वो प्रॉपर्टी ऑफ मटेरियल था सर, वहां पे प्रॉपर्टी ऑफ
परफेक्ट।
मटेरियल था, वो चेंज नहीं
यहाँ पे
होता
फिर
था,
से हम
पर
लोग
यहाँ
एक
पे
बार
क्या है?
डेफिनेशन को फिर से एक बार टच कर लेते हैं, ठीक है। यहाँ पे डेफिनेशन क्या कहता है कि स्पेसिफिक कंडक्टेंस इज दैट कंडक्टेंस, ओके, which is happening by electrolytic ions in unit distance separation with unit surface area. Tanish, clear it?
Yeah.
Now apply that here. Okay. क्या let me put that as small cases, no? मैं पहले क्वेश्चन बाय क्वेश्चन पूछता हूँ, क्या
सेम ही होगा?
सेम ही होगा? चलो समझते
डिक्रीज होगा ना।
देखो यहाँ पर फर्स्ट केस में एज पर द यूनिट्स में बात करता हूँ, दैट इज साइमन सेंटीमीटर इनवर्स, ये था ना, एज पर द यूनिट्स बात करता हूँ, पहले यूनिट्स के बेसिस पे इजी है
Yes,
समझना।
sir.
साइमन पर सेंटीमीटर इनवर्स, कंडक्टिविटी इन सेंटीमीटर इनवर्स डिस्टेंस, है ना। मतलब एक मैं अगर लाइन ऐसे लेता हूं, एक पर्टिकुलर लाइन ऐसे लेता हूं यहां से यहां तक, इस लाइन में कितना अमाउंट ऑफ कंडक्टेंस है कि नहीं एवरीवन? इस पर्टिकुलर लाइन में कितना कंडक्टेंस है? कंडक्टेंस का मतलब क्या होता है? दो चीजें होती है, मैंने बताया आपको दो चीजें, एक होता है नंबर ऑफ आयंस, दूसरा होता है ईज ऑफ फ्लो ऑफ आयंस, ठीक है। यहां से एक आयन जा रहा है आराम से, यहां से ऐसे जा रहा है, कोई आयन जा रहा है, तो उस 1 सेंटीमीटर डिस्टेंस में कितने नंबर ऑफ आयंस है? जितना ज्यादा आयंस रहेंगे उतना ज्यादा कंडक्टेंस, एग्रीड। तो अभी इस लाइन में आप कोई भी लाइन लो, पहले सपोज ये लाइन लेता हूं, इस लाइन पे मेरे पास लगभग कितने मिल रहे हैं? 1 2 3 4 5 6 7 8 ions per centimeter. I was able to see that they are flowing. Now क्या ये 8 रहेंगे? कोई भी एक लाइन ड्रॉ करूंगा।
Yes, sir.
अरे 8 कैसे रहेंगे?
नहीं, ओह सॉरी, आपने
नहीं,
हाँ ठीक है,
water
नहीं रहेगा।
नहीं रहेंगे, अभी कम रहेंगे क्योंकि आपने डाइल्यूट
हाँ,
कर दिया। तो पर यूनिट सेंटीमीटर में नंबर ऑफ आयंस का क्वांटिटी कम हो चुका है कि नहीं? सो क्या कंडक्टेंस ज्यादा रहेगा अभी? नहीं ना, कंडक्टेंस कम रहेगा। ओके, क्योंकि कंडक्टेंस का एस्पेक्ट, इसके लिए कंडक्टेंस समझना बहुत मुश्किल है, क्योंकि कंडक्टेंस सॉलिड में क्या है, कॉन्सेंट्रेशन कभी चेंज नहीं हो रहा है, बट लिक्विड्स में कंडक्टेंस दो तरीके के आ रहे हैं। एक तो यार नंबर ऑफ आयंस बढ़ने पर भी कंडक्टेंस बढ़ रहा है, दूसरा उनके बीच में सेपरेशन बढ़ने पर भी कंडक्टेंस बढ़ रहा है। सेपरेशन बढ़ने पर कंडक्टेंस क्यों बढ़ रहा है? क्योंकि मोलर, इसी के लिए हमने डिफाइन किया उसको मोलर कंडक्टेंस की तरह, क्योंकि सेपरेशन बढ़ने पर आयंस काफी इजीली फ्लो हो जाएंगे। उसको कोई पॉजिटिव वाला चार्ज, यहां से नेगेटिव वाला चार्ज आ रहा है, पॉजिटिव वाला कहीं दूर है, पॉजिटिव चार्ज कहीं दूर है, तो यार वो अट्रैक्ट नहीं करेगा ना, तो वो इजीली फ्लो हो जाएंगे दोनों के दोनों। तो डिस्टेंस भी हेल्प करेगा कंडक्टेंस को, और नंबर ऑफ आयंस भी तो हेल्प करेंगे। ज्यादा नंबर ऑफ आयंस होंगे तो ज्यादा कंडक्टेंस होगा। ये लॉजिक बैठा सबको?
सर एक डाउट है
नहीं बोलो
सर, पर इसके मोबिलिटी पे कैसे कमेंट करेंगे कि आयंस की मोबिलिटी बढ़ी या कम?
मोबिलिटी चेंज नहीं हो रहा है ना, मोबिलिटी सेम आयंस ले रहा हूँ।
नहीं सर, पर वो बोल रहा है कि
वो
आपने
बात
बोला
है।
था कि आयंस बढ़ेंगे तो मोबिलिटी कम हो जाएगा,
ना
पर वो
मैंने
दूसरे
मैंने नहीं
मतलब
बोला,
वो
मैंने बोला उनका इजीनेस कम होगा। ठीक है, मोबिलिटी चेंज नहीं होगा। मोबिलिटी एक आयन के लिए स्पेसिफिक होगा किसी भी सॉल्यूशन में। टेम्परेचर कांस्टेंट है तो उतना ही रहेगा। लिथियम प्लस का मोबिलिटी चाहे आप 1 मोलर कॉन्सेंट्रेशन में लो या 10 मोलर कॉन्सेंट्रेशन में लो, मोबिलिटी उतना ही रहेगा, बट उनकी कंडक्टेंस डिफरेंट हो जाए। समझा बेटा हमें?
यस सर। सर तो ये केस में आपने नंबर ऑफ आयन सेम रखे, सिर्फ वॉल्यूम चेंज कर दिया।
हाँ, मैंने देखो डाइल्यूशन बोला, डाइल्यूशन का मतलब क्या होता है?
हाँ
I'm
सर,
not
समझा।
changing number of moles of solute, I'm just adding solvent, water add किया मैंने। Clear on that everybody? So yes, so per centimeter the conductance is decreasing, so kappa value should decrease, है ना? kappa value decrease हो रहा है।
हाँ
And
सर।
what about C value, concentration? concentration भी decrease हो रहा है,
डिक्रीज।
क्योंकि आपने डाइल्यूशन किया। तो पहले यहाँ पर सोचो C1 है, यहाँ पर C1 है और ये C2 है, ठीक है? So obviously I can say that kappa 1 is less than, sorry, kappa 1 is greater than kappa 2 and C1 is greater than C2. Now dilemma comes that what happens to lambda m? एक तरफ है कंडक्टेंस कम हो रहा है, स्पेसिफिक कंडक्टेंस, और दूसरी तरफ से कॉन्सेंट्रेशन भी कम हो रहा है। कॉन्सेंट्रेशन से इजीनेस बढ़ रहा है, कंडक्टेंस से नंबर ऑफ आयंस इन ए सेंटीमीटर कम हो रहा है, करेक्ट? बट सिंस molar conductance is defined per 1 mole, right? So ये पूरे 1 mole concentration को, 1 molar को सबको मैं चेक करूंगा ना, सारे आयंस को। It has nothing to do with dimensions of the cell. Dimensions आप बड़ा रखो छोटा रखो, 1 mole आयंस के लिए कंडक्टेंस कितना है, ठीक है? सो यहाँ पे नंबर ऑफ आयंस कम ज्यादा होने का चांस ही नहीं है, हमको हमेशा 1 मोल चाहिए पर मोल। So therefore molar conductance mainly depends upon the second factor, that is concentration. kappa पे डिपेंड करता है बट इट इज नॉट अ वेरी बिग कॉन्ट्रीब्यूटर। बस ये आपको मैथमेटिकल टर्म्स में समझा पाऊंगा दैट बोथ ऑफ देम आर डिक्रीजिंग बट द डिनोमिनेटर डिक्रीज इज मोर ड्रास्टिक। ये स्टूडेंट्स, kappa भी कम हो रहा है तो आपको मोलर कंडक्टेंस कम होना चाहिए, बट कॉन्सेंट्रेशन उससे काफी स्केल में कम हो जाएगा।
उसके पीछे का लॉजिक एक बार बता सकते हैं?
हाँ देखो kappa was only depending on per centimeter ना,
यस सर।
but concentration is depend upon the entire volume। तो कौन सा फैक्टर ज्यादा है?
वॉल्यूम।
Yes, that is why
C1
second factor is more dominant. Everybody have you got this point? यहीं पर पूरा लॉजिक क्लियर हो जाना चाहिए, उसके बाद आपको इजी होगा प्रॉब्लम सॉल्विंग। समर्थ,
Yes.
have you understood?
Yes,
No?
sir. Yes, sir.
Okay. No? Yes बेटा अंश।
सर एक बार बस आप रिलेशन रीजन लिख सकते हैं, y(k1 is greater than k2 and y(c1 is greater than c2)।
मैंने लिखा है शायद, डिपेंड्स अपॉन, हाँ इधर लिखा है देखो, conductivity depends upon number of charged particle per unit volume. Therefore, the conductivity of decreases with dilution. ठीक है, conductivity molar conductance is an additive nature. वो मतलब नीचे लिखा और वो पॉइंट भी लिख देता हूँ. देखो यहाँ पे लिखा है kappa is decreasing on dilution, दोनों decrease हो रहे हैं, but the magnitude of m is much more than the decrement of k. That is why lambda m is overall increasing. ठीक है बेटा.
Okay, sir.
यहाँ पर अच्छे से केस स्टडी समझो तो आपको बाकी सारे टर्म्स इजी हो जाएंगे. राइट. So we have learned what is molar conductance, how it is to be written. Now molar conductance can be written either in terms of centimeter per cube, right, when we write the concentrations, or I can write that in terms of meters per cube also, meter cube also. So molar conductance lambda m will be equal to kappa into 1000 by C when the units are Siemens centimeter square per mole inverse, or it would be kappa into C, kappa into 10 raised to power of minus 4 by C if it is Siemens meter square per mole inverse. Correct? This is what you will have if it is meter square. क्योंकि अभी kappa को हम लोग सेंटीमीटर पर मीटर लिखेंगे और कॉन्सेंट्रेशन को भी मोल पर लीटर लिखेंगे, मोल पर मीटर क्यूब लिखेंगे. So in that case, this will be the formula for that. Okay. Everybody understood this point? So meters में और centimeters में कैसे conversion? Right. Okay. Now let us see what is equivalent conductance. Equivalent conductance is the same definition of what molar conductance is. Instead of 1 mole, here the logic is about 1 equivalent. That's all. So we need to have 1 equivalent of the dissolved electrolyte. Therefore, lambda E can be defined as kappa divided by normality. There it was molarity, here it is normality. That's it. Here the units are Siemens centimeter inverse, and here the units are equivalent per liter. If I convert the same in terms of centimeters, I will get this as kappa into 1000 divided by normality, and units now will be Siemens centimeter square per equivalent inverse. That will be lambda, and this is what we'll be using a lot. इसको हम लोग ज़्यादा use करेंगे. Okay. Any doubt here? All it is defined for equivalent, per 1 equivalent. Now it is not depend upon the cell dimensions. It is only depend upon what is the best conductance you can observe when you have 1 equivalent of electrolyte in the solution. Okay. So whatever I discussed, I wrote that in points. See, I'll read it once again. First, conductivity depends upon number of charged particles per unit volume. Therefore, conductivity of electrolytic conductor decreases with dilution. Okay, this is specific conductance. Conductivity and specific conductance is same. Second point, conductivity, molar conductance or equivalent conductance. Equivalent conductance, all are additive in nature, which means, for example, if I take 2 cells and add them up, या 2 electrolytes and add them up, ठीक है? So I can say electrolyte 1 plus electrolyte 2. इससे conductivity, इससे kappa 1 K1 है, इससे kappa K2 है. दोनों को mix करने के बाद now the resultant K will be equal to K1 plus K2. And similarly, if this is lambda 1, lambda m1, lambda m2, then lambda m resultant will be lambda m1 plus lambda m2. They are all additive in nature. Conductance will always be additive. So more the number of ions, you keep on adding them. Suppose, और यहाँ पर क्या है आपका accordingly concentrations change हो जाने चाहिए. So आप suppose आपने 1 molar, किसी का पहले हमने लिया 1 liter 1 molar, right? And one more ion is there which is also 1 liter 1 molar. On adding both of them, Now the concentration becomes half and half. बस वो point ध्यान रखना है. Rest molar conductance will be added. The respective molar conductance in the solution will be added. Same is the case with equivalent conductance. If you have equivalent conductance here, so resultant equivalent conductance is also additive in nature. Got it? So conductance are usually additive. Resistance are not additive like this. Okay, that you have seen it even in the metallic conductors. Resistance easily add नहीं कर सकते हम लोग. That depends upon the type of current which is flowing, है ना? Next. Here, if we have seen this, that molar conductance and equivalent conductance both will increase on dilution. Okay, for both weak as well as strong electrolytes. Kappa is decreasing on dilution. Conductance, equivalent conductance and molar conductance, both of them, you know, their concentrations are decreasing here. But overall, you will see this is an increase here, this is an increase here. So this is what we'll observe. So the magnitude of decrement in M is much more compared to the decrease in the K value. So lambda M will increase. Now this is a part which is more peculiarly asked in JEE. That is, how do we relate lambda M versus lambda E? By definition, let me write down lambda M as kappa into 1000 divided by molarity, while lambda E is defined as kappa into 1000 divided by normality. You know, how do we relate molarity and normality, students? Normality is equal to molarity into valency factor. No, this is how we define. So instead of normality term, I can use this as molarity into valency factor. So I can write lambda E is equal to kappa into 1000 divided by molarity into valency factor, which is equal to lambda M into 1 by valency factor, or that implies lambda M is always equal to valency factor into lambda E. Okay, VF is valency factor. I want all of you to practice this because यही questions में हम लोग ज़्यादा use करेंगे. So valency factor कैसे relate करेगा molar conductance and equivalent conductance. Okay. So you can see valency factor when it relates to ions na beta, it will either be 1 or greater than 1 most of the time. Correct. यहाँ पे कोई disproportionation जैसा cases नहीं है. So it is simply a display of number of ions. So therefore, in most of the cases, you will see lambda M value will be greater than or equal to lambda E. Either valency factor will be 1 or greater than 1. Okay. एक example करके बताता हूँ मैं आपको. देखो, lambda M of Al2SO4 thrice. I need to figure out what is lambda M of Al2SO4 thrice. Let me put it as X. Okay. And I'm writing lambda E of Al2SO4 thrice as Y. Now, my idea is to relate both of them. Can I write that lambda M of Al2SO4 thrice is equal to 2 times of lambda M of Al plus 3 plus 3 times of lambda M of SO4 2 minus क्या मैं लिख सकता हूँ? I just told you that it is additive in nature. So दोनों ions रहेंगे तो उसको हम लोग add कर सकते हैं. Positive, negative जो भी है, total conductance will be the addition of positive ions and addition of negative ions. Clear everyone? And why did I multiply 2 beta? If I take one electrolyte, solution में कितने electrolyte दिखेंगे? 2 moles of 1 mole of electrolyte. If I take it, I take 2 moles of Al plus 3 ions and 3 moles of SO4 2 minus ions. Correct?
Yes.
Now, if we write 2 into lambda M, this molar conductance in terms of equivalent conductance. अभी हमने formula learn किया है that molar conductance is equal to valency factor into equivalent conductance. So I can write that lambda M, correct? I can write it as valency factor into equivalent conductance. Now tell me, what is a valency factor of Al plus 3? That is 3. Because एक salt का valency factor क्या होता है? The charge it carries. So 2 into 3 into lambda E of Al plus 3 plus 3 into 2 into lambda E of SO4 2 minus. So which is equal to 6 times lambda E of Al plus 3 plus 6 times lambda E of SO4 2 minus. So if I just take 6 common, I will get this as lambda E of Al plus 3 plus lambda E of SO4 2 minus, and 6 times of this is what we define it as lambda E of the lambda E of Al2 SO4 thrice, which is equal to 6 times of Y, and this is X. So I hope all of you got this, and that is what we have defined, no? Lambda of any ion, if it is in terms of ions, multiply that with the valency factor of ions. If it is in terms of electrolyte, multiply that with the valency factor of the entire electrolyte. Entire electrolyte valency factor is 6. Any doubt here? Everybody understood that?
No, sir.
Perfect. Now listen up, students. When it comes to electrolytes, we will always have either a strong electrolyte or a weak electrolyte. And when two electrolytes are present, when we compare a strong electrolyte and a weak electrolyte, how would the lambda m value, that is molar conductance value, changes with changing in dilution, changes with changing in concentration, is what we are trying to figure out. Or this is done experimentally also. That also brings to the logic कि सर हम लोग एक्सपेरिमेंटल करने के लिए लैम्डा एम तो कैलकुलेट करना चाहिए ना हमको, बट लैम्डा एम आएगा कहाँ से? That comes from Wheatstone bridge. I'll just show that here once.
सर
हाँ बेटा,
सर अभी आप नोटिंग करने के लिए कह रहे हो कि
क्या बेटा?
ये सब आप नोट करने के लिए नहीं बोले हो ना अभी?
ये वाला नहीं,
अभी
आप
जो
इसको
पढ़ा रहे हो
आप ये वाला नोट करने को बोला, ये फॉर्मूला नोट करने को बोला, ठीक है?
अच्छा नहीं, और इसके पहले आप कह रहे थे ना सर कि नोट करते चलो वो
हाँ
सब
बेटा
इसके
देखो,
बाद
यहाँ पे ये जहाँ पे डेरिवेशन आ रहे हैं जो कि फॉर्मूला याद करना है प्रॉब्लम सॉल्विंग के लिए, वो याद करो, क्योंकि
अच्छा
प्रॉब्लम्स के टाइम पे आपको फॉर्मूला चाहिए ना, ठीक है?
yes,
Otherwise I'll share the notes anyways, right? Don't worry.
yes.
Now my question was here, एक बार Wheatstone bridge को याद करते हैं, just it will be useful for you from physics point of view also. See, if we have any battery connected to cell like this, connected to various resistance like this, so from here current is going, right? So if there is a resistance R1, R2, R3 and R4, correct? We can relate this resistance when the flow in this particular circuit I is equal to 0, है ना? यही Wheatstone bridge होता है. आपने सीखा Wheatstone bridge बेटा?
Yes.
Okay. So now tell me, how do we relate the resistance here?
R1 by R3 is equal to R2.
R1 by R3 is equal to R2 by R4. All of you clear on that? Now, what I'm saying, if one of this, I take one Wheatstone bridge and replace this with conducting cell. A conducting cell लगा दिया. Okay. So then the resistance for that is R4, let's say. Then from here, can I calculate R4 beta? So practically
Yes, sir.
possible hai na? So I can calculate R4. Once I get R4, from R4 I would be able to figure out from R4 I can calculate what is conductance. Uska conductance pata chal jayega. And cell dimensions are in my hand. So from there we can calculate kappa. So kappa will be equal to conductance into L by A. So that way we will be calculating kappa. Directly हमको, you can have different monitors. सेंसर्स, वो सेंसर से आपको K वैल्यू मिल जाएगा. So K वैल्यू से हम लोग लैम्डा m वैल्यू इवेल्युएट कर सकते हैं on changing the concentration. So this is in our hands now. So I'll keep changing the concentrations every time and see how much is the lambda m value changing. I think all of you got the point now, how we are plotting the graphs. So that's how. First, we will take it from strong electrolyte. For strong electrolyte like KCl, NaCl, when you add it to water, we are trying to figure out how the lambda m value is changing. When it comes to strong electrolytes, beta, this is, see, मैंने फिर भी इतना variation लिखा है, but in a longer scale of concentrations, ये almost linear ऐसे दिखेगा for a very long range of concentrations. ठीक है? Which means the change in the concentration, if you take it for a very long graph, hardly any changes observed. Which means even at this concentration, even at this concentration, even at this concentration, the change in the concentration is very less. Yeah, beta. And it would definitely have one maximum when the concentration is almost zero, right? When the concentration of the ions is almost zero, that is at like an infinite dilution hai, तो उस time पे lambda m maximum रहेगा, correct? So we take 1 mole of a substance, 1 mole of NaCl लो और बाल्टी भर पानी डाल दो उसमें, correct? So in that case, lambda m value which you will get, that is called the lambda m naught or lambda m infinity. ये दोनों को समझना है. Lambda m naught क्या होता है, infinity क्या? Naught means zero concentration, almost zero concentration पे lambda. Lambda m infinity means infinite dilution. Infinite dilution. And if you observe, both of them are one and the same. So whether you write it as lambda m 0 or lambda m infinity, both उन दोनों का meaning same है. Here everybody.
Sure.
Now for strong electrolytes, this is how it has been found. And that strong electrolyte can be related with a simple linear equation. No? We can relate that with some linear equation, something like y is equal to mx plus c. Okay. And that is what has been done here, that a linear equation has been identified for strong electrolyte. And that will be y is equal to, right? So this is mx plus c. And you can see c is a positive slope, a positive intercept, and the slope is negative because ये value थोड़ा decremental. So it is a negative slope. So you will get this as lambda m naught minus some constant into root c. And this equation is called Debye-Huckel's equation. This is called Debye-Huckel's equation. Okay. So for strong electrolytes, we will be able to get this linear equation very easily. Okay. इसमें बहुत सारे cases है that is not in our syllabus. जितना हम लोग को syllabus में उतने पे हम लोग stick करते हैं. Okay. So this is lambda m is equal to lambda m naught minus some constant into root c. This is what we have seen it in a linear profile for strong electrolytes. But when it comes to weak electrolytes, students, weak electrolytes के लिए पहले वो almost कुछ ज़्यादा change नहीं हो रहा है, but बहुत ही कम conductivity दिखाता है, but drastically it will start increasing after some time, because as now the concentration keeps decreasing, the number of ions will start increasing. Ostwald's dilution law. Everybody, ionic equilibrium, if you recall, what was Ostwald's dilution law? On dilution of weak electrolytes, the dissociation increases. That is, alpha value will increase. Right, student? So that's what is happening. Now the number of ions are increasing, because the number of ions are increasing and relative to that of volume is also increasing. So दोनों में advantage ये मिल रहा है, number of ions बढ़ रहा है, जिससे conductance बढ़ना चाहिए. And we are able to accommodate them with the least amount of interaction because you are using a very high volume. Concentration कम है. Therefore, molar conductance will increase, and experimentally it is very difficult to find out a value at zero. That is, at zero conductance कोई extrapolate करके value नहीं आ सकता है. Obviously zero पे ये भी नहीं आएगा, but इसको हम लोग ये 3 points के basis पे इसको extrapolate कर सकते हैं ना इसको. We can extrapolate and find out what is its lambda m naught. But for a weak electrolyte, we cannot find out that lambda m naught irrespective of whether you extrapolate. Huh? So that value cannot be calculated for weak electrolytes. Now, students, see this value of A, which is a constant value, depends upon the nature of solvent and the temperature at which the electrolyte is dissolved. So if you change the temperature and if you change the nature of solvent, which means if you take some other solvent, the A value will change. Okay. Now, particularly when all electrolytes are of a same type and they have same value of A, correct? That is, if you have like MgSO4, this has +2 and -2, correct? While CaCl2, this has +2, -1. NaCl, this has +1 charge and -1 charge, correct? In that case, the charge is different here. So this A value particularly depends upon the charge if the solvent is same. Okay, students? So you can see MgSO4 will have higher A value compared to that of CaCl2 compared to that of NaCl. But if it is of a same charge like NaCl, KCl, LiCl, they will have almost same A value. Clear? Logic clear, students?
Yes.
Next, from Oswald's dilution law, we know that alpha is inversely proportional to concentration. If concentration decreases, alpha increases. And that's why at infinite dilution, lambda is 1. Okay? Sorry, alpha is 1. Dissociation, degree of dissociation is 1. Now, students, a very important factor is if we want to figure out how much is the lambda m infinite or lambda m naught for a weak electrolyte, we can use the information of strong electrolyte and we can calculate the lambda m infinite of weak electrolytes. And this is done by something called Cole-Rush law. It's supposed to be said that at infinite dilutions, whether it is a weak electrolyte or strong electrolyte, those electrons will be 100% ionized and they behave like an independent ions. What I meant to say, ध्यान से सुनना. Suppose if I take PbCl2, अच्छे से सुनो एक बार, केस स्टडी की तरह सुनो फिर से. I have PbCl2. PbCl2 is a white precipitate जो वाटर में जल्दी डिसॉल्व नहीं होता है. And then I have NaCl. I have PbCl2, I have NaCl. But their conductivity is different at a normal concentrations because normal concentration पे PbCl2 ज़्यादा dissolve होता ही नहीं है. But NaCl almost 100% dissociate हो जाएगा even at a normal conditions. Normal concentrations like 0.5 molar, 0.1 molar वो completely dissolve हो जाएगा. But the minute I'll go for a very dilute solutions, then PbCl2 will also start dissociating, ionizing. Now imagine a situation where there is almost 100% dissociation in both of them. PbCl2 also got 100% dissociated. NaCl will also got 100% dissociated. NaCl लो, आप यहाँ CaCl2 लो, any of that. If for a simple comparison, I can take PbCl2 and CaCl2 also. At infinite dilution, students, the amount of conductivity of Cl minus in PbCl2 and conductivity of Cl minus in CaCl2 will be same. Because वो आयन और ये आयन सेम ही तो है और 100% डिसोसिएटेड है और इनफाइनाइट डिल्यूशन मतलब उनको कोई रोकने वाला नहीं है. दे आर कंप्लीटली इंडिपेंडेंट ऑफ द अदर आयंस. बिकॉज if it is infinite dilution, Cl minus is here, Pb plus is very far away, or Cl minus is also far away, so they do not have much of an interaction. Clear, students? And that is the advantage Cole-Rush is taking. So according to Cole-Rush law, he assumes that definitely at infinite dilutions, ions will behave independently. They do not have any interaction with the oppositely charged ions. Hence, whether it is from X source like CaCl2, NaCl or any other source, or from PbCl2, at infinite dilution, the ionic mobility, the molar conductance of that particular ion, whether it is Cl minus here or Cl minus here, both of them will have same lambda value. Is this logic clear?
Yes, sir.
Right. So that is what he is taking now. So what he says, lambda m infinity, ध्यान से देखना, lambda m infinity of NaCl will be lambda m of Na plus and lambda m of Cl minus. Let me call that उन दोनों का combined amount molar conductance X होगा. Lambda m of KCl will be sum of K plus and Cl minus. Let this be Y. अब ये दोनों का difference लेंगे हम लोग. So I'll get x minus y, which is lambda Na plus minus lambda K plus. Correct? This is x minus y, what I'll get if at all I subtract these two. Clear? Similarly, if at all I take lambda m infinity of Na2CO3, which is W, lambda m infinity of K2CO3, ये दोनों का difference क्या आ जाएगा? You will get this as 2 times of lambda Na infinity and lambda m of K plus infinity, and this will be 2 minus this value, correct? Which is W minus Z. Now can I say that W minus Z, what I calculated from this particular cell, correct, from this particular source, will be same as 2 times of x minus y, which I have calculated from this source. क्या फर्क पड़ रहा है? Na plus K plus कहाँ से आए? वो एक बार KCl और NaCl से आ रहा था, अभी इस बार Na2CO3 और K2CO3 से आ रहा था, उससे कुछ फर्क नहीं पड़ने वाला at infinite dilutions. I hope this point is clear, right, students?
Yes, sir.
Right. So taking this into account, now we can say, suppose if the law states that the limiting molar conductivity of an electrolyte, that is weak or strong, can be represented as sum of the individual contributions of anions and cations, and they can be always used as source for both weak electrolyte and strong electrolytes. Okay. Suppose I'll take one example and show you.
सर ये तो वैसे भी कर सकते हैं ना, मतलब जरूरी नहीं है उसके लिए इनफाइनाइट डाइल्यूशन.
नहीं, सपोज अगर आपको वीक इलेक्ट्रोलाइट्स की बात हो रही है, ठीक है, वीक इलेक्ट्रोलाइट्स में जो Cl माइनस डिसोसिएटेड है, ठीक है, और जो Pb+2 डिसोसिएटेड है Cl माइनस, इस तरीके से, ठीक है, और स्ट्रॉन्ग इलेक्ट्रोलाइट है जो कि Ca+2 है, Cl माइनस है और Cl माइनस है, दोनों को 0.1 मोलर कॉन्सेंट्रेशन पे है. जो इसमें तो थोड़ा डिसॉल्व नहीं हुआ है, उसको उसके बारे में हम लोग बात ही नहीं करेंगे ना. जो डिसॉल्व नहीं हुआ है वो तो आयन ही नहीं है, तो उसके बारे में भूल जाओ. बट अभी आप देखोगे जो डिसॉल्व हो चुके हैं उसमें आप देखोगे तो ये दोनों के बीच में इंटरेक्शंस है अभी भी. गॉट इट? बिकॉज कॉन्सेंट्रेशन एक नॉर्मल कॉन्सेंट्रेशन है, बट इन दोनों के बीच में इंटरेक्शन नहीं है अभी भी. 0.1 मोलर मतलब बहुत कम है, अभी इंटरेक्शन बहुत कम है. ठीक है बेटा? बट इसमें इंटरेक्शन ज्यादा है. जब इनफाइनाइट डाइल्यूशन हो जाएंगे ना, इधर इंटरेक्शन रहेगा ना इधर इंटरेक्शन रहेगा, तो Cl माइनस का यहाँ का वैल्यू और यहाँ का वैल्यू सेम रहेगा. ओके, राइट. सो दैट इज व्हाई स्ट्रॉन्ग इलेक्ट्रोलाइट्स के लिए हम लोग हर कॉन्सेंट्रेशन पे लिख सकते हैं, क्योंकि ऑलमोस्ट सेम ही रहेंगे. लाइक मैंने बताया था, लीनियरली वेरी हो रहा है, वो लीनियर बहुत लॉन्गर लाइन है वो. ठीक है, राइट. एक एग्जांपल देके बताता हूँ तो इजी लगेगा आपको. सपोज इफ यू वांट टू कैलकुलेट CH3COOH, इसका लैम्डा वैल्यू कैलकुलेट करना है. आई राइट दैट एज लैम्डा 1. एंड हमको क्या क्या डेटा गिवन है. CH3CONA, इसका वैल्यू गिवन है, इसका वैल्यू गिवन है लैम्डा 2, और NaCl का वैल्यू गिवन है लैम्डा 3, और HCl का वैल्यू गिवन है lambda 4. ठीक है. Now these three are strong electrolytes, right beta? So at infinite dilution of CH3CONA, इसका वैल्यू आ जाएगा मुझे lambda of CH3CO minus plus Na plus, correct? और lambda of HCl, I will get this as lambda of H plus lambda of Cl minus, and lambda of NaCl, I will get this as lambda of Na plus lambda of Cl minus. Let this be equation 1. Sorry. Let this be equation 2. Let this be equation 3. So and at infinite dilutions, ये सारे infinite dilutions पे ही है. Yeah. At infinite dilution of CH3COOH, because I cannot calculate this value experimentally, I am depending upon the above 3 equations beta. That is what is the importance of Kohlrausch law. So I will be able to generate this equation 4 by using this 1, 2 and 3. How will I get that? इसमें से क्या करना पड़ेगा मुझे? 1 को ऐड करना पड़ेगा, ठीक है, 2 को इन दोनों को सब्ट्रैक्ट करना पड़ेगा, मतलब 3 को सब्ट्रैक्ट करना पड़ेगा और 2 को ऐड करना पड़ेगा, राइट? So therefore
1 plus
4
2 minus
you will get as 1 plus 2 minus 3. Done. So therefore lambda m infinity of CH3COH, which I was not able to do experimentally, now I will be able to get that as lambda 2 plus lambda 3, sorry, lambda 4 minus lambda 3. That will be the value of lambda 1. Now you understood what is the advantage of Kohlrausch law. Clear,
Yes.
everyone? Right. Now, the next important concept based upon the lambda
Sir.
values. Tanish, yes,
So lambda 4 is equal to lambda 2 plus मतलब 4 और 1 को swap कर दीजिए.
ये दोनों को मैंने ऐड कर दिया और इसको सब्ट्रैक्ट किया.
सर नहीं, वो फाइनल बॉक्स जो लिखा है उसमें.
हाँ, lambda 1 lambda 2 सही तो है ना बेटा? इसी को तो सब्ट्रैक्ट करना था और ये दोनों को ऐड किया हमने, lambda 2 को और HCl को ऐड किया हमने, बराबर?
Yes, sir.
कुछ और डाउट था?
नहीं सर, वो आपने वहाँ पे नंबरिंग अलग किया था ना, थोड़ा लैम्डा में गड़बड़ हुई.
अच्छा, ये वाले नंबरिंग अलग किए और ये लैम्डास अलग किए. ओके ओके
हाँ, इसलिए
ओके, ठीक है, वो मैं जल्दी में लिख दिया. आप समझ,
रहने दो सर.
एसेंस समझ जाओ, एसेंस समझ जाओ.
यस यस सर.
भावनाएं पहुंच गई ना मेरी बस.
यस सर.
ठीक है. सो नेक्स्ट लेट अस सी डिग्री ऑफ डिसोसिएशन. डिग्री ऑफ डिसोसिएशन अल्फा. देखो बेटा, in ionic chemistry we learn all about alpha values, degree of dissociations. That all information comes from this. Okay, यहाँ के experimental values हम लोग alpha calculate करते हैं. So degree of dissociation by definition is what, if we, for example, if there is any electrolyte like HAC, एक weak acid की बात करें, so then it will dissociate as AC minus plus H plus, and initial concentration will take it as C naught. C naught into 1 minus alpha, C naught alpha, and C naught alpha. This is how we write down. And from here we write Ka is equal to C naught alpha whole square divided by C naught into 1 minus alpha, which is C naught alpha square by 1 minus alpha. This is what we write, right? इतना हम लोग एक बार याद करो डाइल्यूशन लॉ से, तो ये हमने डिराइव किया था आयनिक इक्विलिब्रियम. Okay. Now I can say if the molar conductance at infinite dilution, okay, infinite dilutions will have an alpha value as 1, will have an alpha value as 1, and for 1 unit of conductance, then how much will be the alpha value? How much will be the alpha value? Alpha value will be equal to 1 divided by lambda m infinity of HAC. Correct? Not related directly, मतलब ये proportional है, ये lambda इसके साथ में proportional है ना? So from here I can say that lambda, alpha is degree of dissociation. So alpha can be defined as lambda m of HAC at any concentration divided by lambda m of HAC at infinite dilution. So you will measure the concentration. First you will check out the concentration और उसके basis पे आप lambda calculate करोगे using Wheatstone bridge and divide that by lambda infinite value, fetching that from Kohlrausch law, and from there you will get alpha value. समझ में alpha values कैसे calculate करते हैं experimentally. So once you get that alpha value, now I can write Ka, and this is how Kas are identified. Kas will be equal to C naught concentration into lambda m by lambda m infinity divided by 1 minus lambda m by lambda m infinity whole square. Sorry, whole square here. This is how we will find out Ka value. And in most of the cases, if it is very weak acids, we know that alpha value is way less than 1, which implies Ka can be written as C naught lambda m by lambda m infinity whole square, right? So this is how we can relate the questions from ionic and electrobeta. I think derivation and all is clear, everyone.
सर वो अल्फा कैसे आया था?
क्या बेटा?
अल्फा 1/लैम्डा m infinity HSC वो समझा, वो नीचे लैम्डा m HSC अपॉन लैम्डा m infinity HSC कैसे आया?
ये 1 के लिए इतना होगा तो लैम्डा के लिए कितना होगा? इनटू लैम्डा ना.
अच्छा, in that sense, okay, yeah, understood.
यूनिटरी मेथड, राइट? सिंपल यूनिटरी. या
हाँ, yes sir.
बचपन में ऐसे सीखते थे ना, पहले 1 के लिए करो फिर बाकी कोई भी एक्स से
हाँ,
वही किया मैं. ठीक है. सो आई होप ऑल ऑफ यू गॉट दैट. और एक डेरिवेशन भूल गया. अच्छा मैंने इधर लिख दिया था रे डेरिवेशन, सॉरी. तो इसका
सर
जरूरत नहीं.
सर वो अल्फा कब तक इग्नोर कर सकते हैं? मतलब आपने 1 माइनस अल्फा पे वो 1 कर
0.05
दिया.
मैंने कल आपको कराया था.
नहीं सर, यहाँ पे लैम्डा के क्या वैल्यूज, मतलब वैसे नहीं समझा.
यहाँ पे लैम्डा के
मतलब लैम्डा का वैल्यू कैसे वेरी करेगा? और मतलब वही रहेगा, मतलब लैम्डा m is 0.05 और लैम्डा m
हाँ,
infinity तब
इन
होगा
दोनों
बस.
का जो डिफरेंस होना चाहिए वो 0.05 के नीचे क्रिएट कर पा रहे हो तो मतलब अल्फा को इग्नोर करो
अच्छा वैसे.
बस. ओके. यूजुअली जितने भी आयनिक वाले क्वेश्चंस होते हैं, एवरीबॉडी लेट मी रिकॉल यू, वी हैव डन दिस बिफोर. वी कैन इग्नोर अल्फा एज लॉन्ग एज इट इज लेस देन 0.05. ओके. नेक्स्ट, डिटर्मिनेशन ऑफ आयनिक प्रोडक्ट ऑफ H2O, दैट इज KW. KW कैसे कैलकुलेट करेंगे? वी नो दैट ionic product IP, right, is equal to H plus concentration into OH minus concentration at any point of time. Okay, so K of water, that is specific conductance of water, can be written as specific conductance of H plus specific conductance of OH minus. Okay, because ions ही है जो conduct कर रहे, so K of water will be H plus and OH minus. So lambda m of H plus will be equal to kappa of H into 1000 divided by concentration of H plus, and lambda m of OH minus will be equal to kappa of OH minus into 1000 divided by OH minus concentration, right? ये लिख सकते हैं. So kappa of water will be equal to, अभी ये KH के टर्म्स में मैं लिखता हूँ. So lambda m of H plus into H plus divided by 1000 plus lambda m of OH minus concentration, lambda m of OH minus concentration into OH minus concentration divided by 1000. So what we can write? So if I bring that 1000 common, right, and H plus, if I take this lambda m of KW, हाँ एक ये लिख सकता हूँ ना, ionic product of water KW is equal to H plus concentration into OH minus concentration for pure water. And for pure water, for pure H2O, we know that H plus concentration is equal to OH minus concentration is equal to under root of 1 by KW. So I can write that here now. So for pure water, so for pure H2O, K of water can be written as K of KW under root divided by 1000. If I take common, that will be lambda m of H plus lambda m of OH minus. This is what we can write. So from here, I can write K of water into 1000, right? That whole divided by lambda m of H plus lambda m of OH minus, that is equal to under root of KW, and from there I will get KW value as square of this. So ये सारे experimentally हम लोग calculate करते हैं और वहां से KW calculate करते हैं. That's how we got that KW value as 10 raised to power of minus 14. Okay, students? ये आपको समझाने के लिए डायरेक्टली इसका यूज नहीं आएगा, कहाँ पे क्या यूज आएगा वो प्रॉब्लम्स के थ्रू करते हैं। देखो, स्टार्ट विद दिस प्रॉब्लम फर्स्ट। इक्विवेलेंट कंडक्टेंस ऑफ लैम्डा ई लैम्डा HCl, दिस इज गिवन। अभी मैंने बताया था, जस्ट उसको यूज करो, इमीडिएटली गेट द आंसर स्टूडेंट्स। First, you will supposed to get equivalent conductance are given. So using equivalent conductance, first calculate this one. That is the first task. And once you get the information of this infinite dilution, and ये given है, इसके basis पे अल्फा आ जाएगा,
अल्फा,
और यहाँ पे C नॉट कॉन्सेंट्रेशन है, सो अल्फा पता चल जाएगा, K पता चल जाएगा। ये टिपिकल जेई क्वेश्चन है। चलो कंप्लीट करो सब।
जेई एडवांस वाला,
क्या बेटा? जेई एडवांस में इसमें और
advanced
थोड़ा
में
ऐड
ऐसे
हो जाएगा। जेई एडवांस में और थोड़ा ऐड हो जाएगा, वाटर का भी दे देगा। दैट्स इट। बट आइडिया यही है, एल्गोरिदम यही है। करो। समर्थ, यस बेटा।
नहीं सर, वो पहले किया था, अगर सी और करना भूल गया होगा।
ओके। So you're doing it for the first time, I would suggest all of you to write all the equations properly.
वो ClCH2 है क्या?
क्या बेटा? ClCH2, yes. ClCH2 CONA. इन सबके यूनिट सेम है, मैंने लिखे नहीं है, बट यूनिट सेम है सबके। ओके। Check if all of you have got that.
yes sir.
Check your answers, everyone, if you have got that. Point 1 by 0.9, no? So ले सकता हूँ 1.1, yeah. 10 raised to minus 2, yes, ठीक है. Okay, Ansh, check it out. Ansh, you want me to explain
sir.
this one? Ansh, beta, should I explain this question? Yeah, okay, listen. So the information given is this: equivalent conductance are given. We need to calculate the equivalent conductance of this weak acid. So using this strong salts information, we can get that. So first I have written NaCl as Na plus plus Cl minus equivalent conductance, HCl as H plus plus Cl minus, and this salt as CH2CO minus and Na plus. And finally I need it for this one, which is CHCl3CO minus and H plus. To get this, you can see how we can add, because I need this in this and H plus on the right hand side, and I need to cancel off all these four. So I need to write 2 plus 3 minus 1. Then everything will get cancelled and you'll be remained with only these two, CHCl3CO minus and H plus. And I have added those 426, 89.8. When you add all of that, you'll get this as 388.8. Okay, Ansh? So that's how we get the alpha E value, beta. Alpha E infinity of Cl CH2COH. And later after that, you calculated alpha. And once you get alpha, you calculated Ka. So I guess the typical algorithm is clear to everyone. How the way to find out using Kohlrausch law and then applying that for alpha value and Ka value and so. इसके बाद से हम लोग कोई भी ionic question में भी जा सकते हैं. From Ka, I can dig into buffer solution or hydration, you know, once you know the Ka value. Done? Everyone clear? Let's go to the next question. We'll have to do a lot of questions better in this area. So थोड़ा जल्दी करते हैं questions. सुनो. Next question. Resistance of 0.1 normal KCl is given 250 ohms. Calculate lambda m lambda e of the solution if the electrode in the cell are 4 centimeter apart. दोनों में distance 4 centimeter है, and having an area of 8 centimeter dipped inside the electrolyte. Okay, area is also given. So from there you can calculate the cell constant. Cell constant आए तो kappa आ जाएगा, kappa आएगा तो lambda आ जाएगा, right? Lambda m आने के बाद lambda e आ जाएगा. चलो करो अभी. I'll give you 2 minutes lead for you, then I'll start. Meanwhile, you finish it. Mayank, are you following, beta? Mayank, respond.
Sure.
Okay. Amal?
Yes, sir.
Hitesh?
Yes.
Chalo, give the answer, beta. I need an answer now from all three of you. Chalo. Put it on chat. Yes, correct, Samarth. If you have the sheet, do the next question now, Samarth. लैम्डा ई आ गया, लैम्डा एम आ गया और लैम्डा ई आपको पता है कितना होगा. Okay, what's equal to 5. See if all of you have got that.
Yes, sir.
I think I've made a mistake somewhere. 20 की जगह I got the answer as 2. तो 2 10 का
वो
factor से मैंने लगता है कि
1/10 वाला मिस हो गया आपको नीचे कॉन्सेंट्रेशन.
yes शायद से वही हुआ होगा सर.
Yeah. Ranveer, Hitesh, is this clear? Shall we go ahead? Right. So the next question now. Solubility and solubility product of this complex in water, we have to find out given the conductivity of the solution of this complex is given. Conductivity is kappa. Given molar conductance of CO plus 2 and these are given. Okay. So the first thing I want you to understand one thing better when it comes to sparingly soluble salts. जहाँ पे KSP involved है, एक चीज आपको अच्छे से याद रखना. Whenever KSP is involved, the other day I think I was explaining. हाँ तनिष में आपको explain कर रहा था याद है. AgCl. The idea here is suppose if I take something like a salt of AgCl, which is sparingly soluble salt. First, it will become an Ag plus aqueous ion plus Cl. Sorry. First, it will get dissolved as AgCl aqueous and maintain an equilibrium K1. And then this AgCl aqueous will undergo dissociation to give Ag plus aqueous plus Cl minus aqueous. And this is K2. The result of these two is what we write it as KSP. We write this as Ag plus aqueous plus Cl minus aqueous. And this is KSP. What is the prime assumption here? We say that the solubility here is defined as S. This is what is we define as solubility S. And not just that, we also write that if that is solubility S here, it will be S minus S alpha, S minus S alpha, S alpha and S alpha. For most cases, as long as nothing is mentioned about alpha, we always take alpha is equal to 1. So can I say that lambda m of salt here for sparingly soluble salt will be equal to lambda m infinity of the salt, because whatever the aqueous form is, जो solid form है उसका कोई मतलब ही नहीं हमको, that is not going to give any conductivity. But whatever that got dissolved in the aqueous form, everything is undergoing 100% dissociation. So lambda m of the salt is always equal to lambda m infinity of the salt, because alpha is always equal to 1 in this case. Is this logic clear, everyone? So if the question is asked about the alpha value, correct, you always take the concentration as a solubility. So you take solubility, that will directly fetch you lambda m infinity, and lambda m infinity and lambda m are same. Now attempt the question. first find the solubility S, and from the solubility you should be able to figure out.
सर अल्फा 1 की होगा, आप एक्सप्लेन कर सकते हो एक बार?
देखो अल्फा किस पे डिपेंड करता है? आयन जो एक्वस सॉल्यूशन में जो इलेक्ट्रोलाइट है वो कितना डिसोसिएट हो रहा है उस पे अल्फा डिफाइंड है ना.
यस सर.
मैं क्या कह रहा हूँ, जो भी स्पेरिंगली सॉल्युबल सॉल्ट्स होते हैं लाइक AgCl, वो जितना भी अमाउंट एक्वस सॉल्यूशन में डिसॉल्व होते हैं, ठीक है, वो डिसॉल्व्ड अमाउंट 100% आयोनाइज भी हो जाते हैं. ओके, ये नॉर्मली हम लोग हमेशा यही अजम्पशन लेके करते हैं, ठीक है. फॉर एग्जाम्पल इफ यू टेक एस्टिक एसिड है तो एक्वस सॉल्यूशन में, एक्वस फॉर्म में ही है, बट पूरा आयोनाइज नहीं हो रहा है ना.
नहीं.
बट इसमें ऐसा नहीं होगा. स्पेरिंगली सॉल्युबल सॉल्ट में यही हमेशा अजम्पशन होता है कि जितना भी अमाउंट एक्वस फॉर्म में कन्वर्ट हुआ है वो पूरा का पूरा डिसोसिएट हो रहा है.
वो पूरा. हाँ
तो
सर
अल्फा
किया था.
हमेशा 1 ही है ना बेटा. तो बस यही हर एक जेई के एडवांस क्वेश्चन में इसी इसी पे ज्यादा पूछा जाएगा जहाँ पे सॉल्युबिलिटी प्रोडक्ट इन्वॉल्व. और सॉल्युबिलिटी प्रोडक्ट जहाँ पे इन्वॉल्व है वहां पे लैम्डा एम इज ऑलवेज इक्वल टू लैम्डा एम इन्फिनिटी.
ओके. यस सर.
चलो अब यहाँ से आपको लैम्डा एम इन्फिनिटी आ जाएगा, लैम्डा एम इन्फिनिटी से सॉल्युबिलिटी आ जाएगा, सॉल्युबिलिटी से केस भी आ जाएगा. बस ऐसे उल्टा करना है. Any answers?
एक सेकंड सर.
And I'll just start the start writing. Don't look at screen. Just keep doing on your.
Sir, can you just scroll up a bit for us?
हाँ बेटा.
Yeah, sir.
Okay. This is the KSP value, beta, Ishan. Correct. Very close. 2 by
सर केएसपी बहुत ही कम है क्या?
KSP कम ही आएगा ना हमेशा.
हाँ
हाँ करेक्ट. -18 कैसे आ रहा है? -15 आना चाहिए.
यस सर, आई चेक वन।
हाँ मुझे 15 आया था. ईशान करेक्ट. Solubility is correct. KSP. These two are the values which I'm getting. Look, everyone.
सर वाटर का कोई कंडक्टिविटी नहीं होगा क्या?
किसका बेटा?
वाटर का?
वाटर का इग्नोर कर रहे हैं, बट क्वेश्चन में दिया है तो वाटर को सब्ट्रैक्ट करने का पहले. ठीक है.
हाँ हाँ ठीक है.
कुछ क्वेश्चन है आपके पेस के बुकलेट में जहाँ पे वाटर दिया हुआ है. जैसे ही वाटर देते हो आपको जितना ओवरऑल कंडक्टिविटी देता है उसमें से वाटर का पहले हटा दो, फिर सॉल्व करो.
मतलब ये 206 में से हटा देंगे ना?
हटा देना, वाटर हटा देना उसमें.
हाँ यस अंडरस्टूड.
फिनिश एवरीवन. गेस सबको आ गया ये?
यस.
चलो नेक्स्ट क्वेश्चन पे फोकस करो अभी. Resistance of solution A and solution B is given. Both solutions are taken in the same conducting cells. If equal volume of A and B are mixed, what will be the resistance of the mixture? I told you, like, we can add the conductivities, not resistance. So use that logic and get it. अथर्व लास्ट क्वेश्चन हुआ बेटा. अथर्व, वेदांत, respond. Vedant, have you understood the last
So
question?
total conductivity 3L by 500 ये आता है.
पहले वाला या ये वाला?
नहीं ये नया वाला.
रेसिस्टेंस, कंडक्टेंस की बात करो बेटा. 5
हाँ सर कंडक्टिविटी.
टोटल कंडक्टिविटी कितना आ रहा है?
3L by 500
हाँ एल और ये ए का वैल्यू तो पता है ना.
हाँ सर.
200 into L by A. L कितना है? Very good, Samal. Correct. Very good, Amal. Correct. Yes, Isan. Correct. Yes, Atharu. Right. So those who finish can go to the next question. Amal, Samarth, Ishan, Atharu. You guys can go to the next question. K resultant will be equal to Ka plus Kb. Yes, we can write it as K resultant will be G dash by R resultant will be equal to G dash divided by Ra plus G dash divided by Rb. G dash will get cancelled. Got it? Only thing that you need to check out here is when it comes to G dash here, G dash normally is L by A. Okay, L by A here. So here A has been increased twice because area is increased 2 times here. So therefore G dash will be 2 times of LA. So that's how we can write down this as 2 times of G dash. Got it. So yeah, so we'll get this as G dash 2 times divided by resistance is equal to 1 by 50 plus 1 by 100. So which implies 2 by R of resistance is equal to 3 by 100. So resistance will be equal to 200 by 3. So 66.6 ohms. Done? Everybody clear on that? Tanishq, clear on this question?
Yes, sir.
चलो नेक्स्ट क्वेश्चन पे आ जाओ सब लोग. Lambda E of 0.1 normal solution of MgCl2 is given. A conductivity cell with electrodes that are 15 centimeters square in surface area and 0.5 centimeter apart is fitted with 0.1 normal MgCl2. How much current will flow when the voltage difference is 5 volts? Just to remind you, voltage difference is equal to I into R, if you recall from physics. Yeah. Use that logic. First calculate the resistance. Once you get the resistance, you can get I. milliamps, right? Dave, is that milliamps?
Yes, sir.
Yeah, milliamps is fine. But why did you use milliamps? मतलब डायरेक्टली एम्प में क्यों नहीं लिखा आंसर? बिकॉज रेसिस्टेंस तो हम लोग को सीधा ओम्स में ही आएगा ना, और वोल्टेज हम लोग को वोल्टेज में दिया
सर
हुआ है।
मैंने वो डायमेंशंस को सेंटीमीटर्स में
अच्छा
दिया
अच्छा,
है।
ओके ओके। सेंटीमीटर्स में लेने पर रेसिस्टेंस का यूनिट्स चेंज नहीं होगा ना, ओम ही आएगा। तो आपका जो आंसर होगा वो मिली एम्प्स होना चाहिए फिर, नहीं तो सिर्फ 1.5 ही होगा आंसर। एम्प्स तो 1.5 होगा देखो।
एम्स 1.5, हाँ।
हाँ राइट, सो आ गया तो नेक्स्ट क्वेश्चन करो। See others if you have got that. Yeah, okay, Dev. Right. Right. Everybody got that? Check करो एक बार आंसर सब लोग। Arnav, check your answer if you have got this.
हाँ सर।
Arya, hi beta. Aradhya, did you follow this beta? You got this? Okay. Right. So let us do the next question. A big irregular shaped vessel containing water, the specific conductance of which was given. 585 grams of NaCl was then added to water, and specific conductance after addition of NaCl was found to be this much. Find the capacity of the vessel if it is fully filled with water. Okay, so we need to find out the volume of that container, correct? And lambda infinity of NaCl is given, and specific conductance of water is given, and specific conductance of NaCl in water is given. Okay. Samarth, I think you know now what to do.
Yes, sir.
Others, whenever conductivity of water is given, always remove it from the total solution. So NaCl aqueous solution का आपको conductivity पता है, ओनली वाटर का कंडक्टिविटी पता है, तो रिमूव द वाटर conductivity from the aqueous solution of NaCl. So you'll get conductivity of only NaCl ions. So from there calculate lambda m infinity, and from there you can calculate what will be the volume. Number of moles are given. So number of moles into number of moles divided by molarity, you will get volume. Try that. Any answer fast? I'm putting up solution here meanwhile.
और एक
Yes,
मिनट
yes.
आप कर सकते हैं। Yes, I know.
सेंड किया। अच्छा ये सेंटीमीटर क्यूब में ना समर्थ, लीटर में लिखोगे तो 5 आ जाएगा।
हाँ।
बराबर, ठीक है, बराबर है बेटा। See everyone, if you have got that.
Yes, sir.
Right. So अब सबको आइडिया मिल रहा है ना कैसे क्वेश्चंस पूछे जाते हैं जेई में. So these are the types which have been majorly asked from this section. Okay. Let's do one last question. Do this. H plus A OH minus हटा देना. Yes, HCl. We have this. Then what is the case? So first question is easy here. So lambda m of NaOH. Need to check that as kappa of NaOH into 1000 divided by concentration. So concentration C, which is kappa is 0.02 into 1000 divided by 0.1 originally. So this was 200 ohm inverse centimeter square and mole inverse. Next, lambda m, lambda of NaCl now, correct? NaCl together. Now we have to take NaCl, this plus NaOH together, both of them. Now lambda of NaCl plus NaOH will be, kappa has now changed to 0.06 into 1000 divided by concentration, correct? Now what has happened here is the concentration of NaCl here, sorry, concentration of NaCl where NaOH is already included in it. So I'm not writing it as NaOH separately here, but here including NaOH, this is the concentration which we have. And concentration here is given as further addition of volume V of, 0.1 molar, equal volume. So since it is equal volume, it has to be 0.1 by 2. So it is 0.006 into 1000 into 2 divided by 0.1, right? So that is coming out to be around 120 ohm meters centimeter square and mole inverse. And lastly, HCl. Again, HCl, when you are adding, already we have NaOH and NaCl present in it. Based on that, overall conductance, we are getting that as 0.018 into 1000 divided by concentration is 0.1 divided by 2 again, because again you are adding the same volume further. Sorry, divided by 3 here, because volume has increased by 3 times. So that will be equal to 0.018 into 3 into 1000 divided by 0.1. So that will be equal to 118 into 3 into 10 raised to power of 3. So which is 540 into 10 raised to power of minus 2. 1, 2, 3. 10 into 3. So 0.18. So 2. Yeah, fine. So 540 ohm inverse, centimeter square, and mole inverse. So these are the values which have been asked. Done. Clear, everyone?
Yes, sir.
Right. So these are the types of problems which are usually asked. The last part which is remaining is that we'll discuss in the next session. That is about just a type conductometric titrations. Just like how we have titration graphs for ionic equilibrium, strong acid, strong base, weak acid, strong base, weak base, strong acid. Same graphs this time instead of pH. Instead of pH, now we'll be using lambda m versus the volume of NaOH. That's it. Okay. So this requires a bit of discussion, maybe an half an hour discussion. That will be that will bring to a closure for this chapter. Okay. So I would suggest please start solving the sheets which I have given you. Complete that, and once we're done with that, we'll go for the next topic. Whatever doubts you have, guys, please post it. So next Saturday session we'll have doubts related to hydrocarbons, as well as any doubts from electrochemistry. Okay.
Sir, could you upload the benzene's third lecture to